Hi, my name is Benjamin Hahn. I'm a staff engineer on the AISQL team at Snowflake, based in San Francisco, and today I'm going to be presenting on Cortex AI SQL. This project began about a year ago, and I launched to customers just in June this year. We've grown from about 5 engineers to 60, working mostly in San Francisco and Warsaw, Poland. Okay, so here's the agenda for today's talk. I will talk about Cortex AI SQL, starting with an overview of the AI offerings at Snowflake. We'll do a deep dive into my team's work in AISQL. I'll share a quick recorded demonstration on how customers may interact with SQL for feedback analysis, looking at reviews. We'll do a little bit of a deeper dive on the performance optimizations that make AISQL a valuable product. And then we'll do a quick peek into the future of how low-level AISQL primitives support higher-level agents like Snowflake Intelligence. Most of the content you'll see today is derived from our paper, Cortex AI SQL, a production SQL engine for unstructured data. And this just published earlier this week. There's also an accompanying blog we published last week called Optimizing Query Execution in Cortex AI SQL. OK, so Cortex AI SQL. Our goal in Cortex AI SQL is to provide efficiency, ease of use, and trust benefits from the full Snowflake SQL platform to generative AI features. At the foundation, we have a fully managed set of models, which are great for things like processing text at scale, sentiment analysis, custom summarization using Snowflake models like Arctic or other leading models from companies like Mistral. We provide multiple code interfaces like SQL, Python, and REST, as well as a web interface called Snowflake Studio for no-code development. So I'll go from the top to the bottom of this stack. We have a number of agentic flows. Snowflake Intelligence is our first-party agent for interacting with your company's data. We also offer Cortex Agents, which is a REST API to develop your own custom agents. Below that, there's a layer of information retrieval systems for use cases like RAG. Cortex Analyst is for querying data in structured tables like traditional SQL, while Cortex Search enables unstructured file search from documents. Finally, at the bottom, there is a layer of scalable primitives, including document processing for extracting, parsing, and embedding documents, and finally, Cortex AI SQL. So today, I'd like to focus on Cortex AI SQL. This is one of the key building blocks that powers many of the higher-level agentic features like Snowflake Intelligence. Our goal in AISQL is to integrate LLMs with a database by providing new primitive operators into the query language. This enables easy composition with existing SQL syntax like CTEs, group by joins, where clauses, and many performance benefits I'll discuss later. Using SQL, we get a benefit from a lot of existing governance features like role-based access control for free. OK, so Cortex AI SQL. What is Cortex AI SQL and what does it provide? Cortex AI SQL transforms SQL into an AI query language. At the lowest level, we have AI Complete, which provides low-level LLM calls into SQL queries. All you have to do is choose a model, add a prompt, and then point to your data. This can be done in SQL, Python, or REST API interfaces, or as a tool in higher-level agents, like the Snowflake Studio or Snowflake Intelligence. AISQL is not just raw, low-level LLM integration. We also provide a suite of managed functions that only require the natural language instruction. For example, you can run a query on transcripts with a where clause using AI filter, providing a simple instruction like, was the customer satisfied in the transcript or survey? These functions also use multimodal models using image files. The same filter can be used to join across multiple tables with an instruction like, does the ad image contain this product, or do these two ads target the same demographic? Finally, we enable aggregation using group by with AI Ag. For example, customers often run queries asking, what are the top 10 complaints for my product? Or please summarize these papers for a graduate-level seminar for computer scientists. Using SQL, these primitives can be composed with SQL semantics for common table expressions, where clauses, and joins. Under the hood, we'll take advantage of the SQL Query Planner and make significant optimizations in both the physical and logical plans. Finally, SQL also provides significant governance features, including role-based access control, budget constraints, and data encryption. So in this example, we might have an executive asking a question like, What is the yearly growth, revenue, and market outlook for companies that have recently undergone a CEO change in the renewable energy sector? Cortex AI SQL answers this question, firstly with a CTE retrieving the subset of companies in the renewable energy sector that have had a recent CEO change based on recent earnings report transcripts. We will then join these filtered companies with market research and articles that reference the company using AI filter. Finally, we can then group all of the relevant articles by the company ticker to get a summarization of the future outlook using AI Ag. Okay, I have a quick demonstration of how an analyst might interact with AISQL. In this recording, Derek will present a generated data set of customer views, and he wants to identify some recurring topics.
Hi, my name is Derek. I'm a research scientist at Snowflake, and I want to share with you how to do topic discovery on large text data sets on Snowflake. So let's start by looking at the data. We prepared a sample of data that we share along with the code of the Streamlit application in our examples repo. And when I take a look at the sample, I can see there is a bunch of structured data, and there is our text column with the reviews. You can see, actually like with large data sets, it can be hard to read through all of these reviews and create your own opinion about the categories. But we have the AISQL function that can look at the whole data set and respond to our questions about the data set. So here specifically, we want to look at the product reviews and find out categories. The categories might be, in our case, what product features or aspects customers mention while talking about their satisfaction or dissatisfaction with the product. We can ask different prompts about this data set. Maybe we want to understand the types of customers or the types of products they talk about. So this is a very open-ended function. Here, we're looking at aspects that maybe we can later use in a classification model or in AI sentiment pipeline. So let's run this analysis. And we get a list of 20 different topics or themes or categories that the AISQL function found in this dataset, in the sample of the dataset. So what I like to do in the next step is see the distribution of these topics or themes in our data. And to do this, we can use a classify. So first, let's extract categories from that previous output. The original output of AISQL is in Markdown. We want to fit a comma-separated list of categories into AI classify, and we use AI complete to convert it. We also added this other category to find out any potential outliers. So now let's run a classification pipeline with our discovered categories and see the distribution of these categories in our data set. We can now see the classification summary. There are 13 unique labels found in the sample of the data set. We can see value for money is a big theme, material quality, fitness, or the fit of the product, durability. But there's also this other category. And we probably don't want to have so many outliers. So what we can do is we can look at a sample of text in the other category, but we can also run this outlier analysis using AISQL again. So let's just look at the text that were classified as other. Let's give the prompt to the LLM to analyze this text and find out what categories are within this other category. And hopefully this will give us some insights, some better insights about what we might have missed in the first step. Now we can look at the outlier analysis, and we can see, the biggest theme that the LLM found is lack of specificity. So these texts are brief, lack specific details, binary opinions, good, bad, limited vocabulary, lack of context. So to verify this, maybe what we can do is expand on our list of categories. So let's add short generic review to the list of categories for AI classify and run classification again. and see if this captures this other category that we previously identified as outliers. So let's take a look at the results. And indeed, short generic reviews is the biggest category now. So maybe this is something we can filter out. These reviews don't really contain any useful information about satisfaction themes. But beyond this, we found performance doing specific activities, value, fit, and durability as the biggest drivers of satisfaction or dissatisfaction. So hopefully this demo has been useful to you. You can play with the data set that we provided and see if this set of SQL functions and this methodology is helpful for your data sets and your production pipelines.
Cool. So in this demo, Derek provided an example of a human in the loop iterating on this pipeline and resolving issues with uninformative reviews being tagged as other. Once an analyst is satisfied with all of their results, they could then ship this into a recurring ETL job, possibly to generate features for a downstream model or to power a live dashboard. OK. So we've introduced AISQL and what it provides. Let's talk a little bit about how it works and why it's a good product. This is a pretty dense slide, so I'd like to spend a little bit of time on this. Here we have a query that is trying to do a summarize ag call on a bunch of papers. And we want to do a join looking for paper images that map to this corresponding paper. And we are also going to have some filters on which papers and images we think are going to be most interesting for this analysis. So we have a traditional SQL where clause using a date filter between 2010 and 2015. And then there are two additional AI filters looking for abstracts that describe energy efficiency, and then images that reference this TPCH benchmark workload. So on the left is a traditional SQL query plan where we are minimizing join costs. Historically, for a query CPU bound execution, the join is usually the most expensive thing. So this is what you might do before if you had a naive implementation. So on the left, we have plan A using a strategy that is minimizing the cost of the join. We have 10,000 papers. We have 100,000 images. To minimize the size of the join, we will execute all of these filters first. The issue with that is that that's going to lead to 110,000 LLM calls executing on every single paper and every single image. Instead, on the right side, we have an optimized query plan that is minimizing the number of LLM calls. So this type of query optimization isn't a new field. These types of optimizations have been around for decades, and AISQL benefits as a result of all of them. In this case, we will handle the filter for the images at the last stage only after the first CPU-bound filter has been executed first. In this case, we only get 300 results. And then after the abstract filter has been made as well. In the end, we only get 330 LLM calls. We have some other optimizations for AI filter. We can treat the AI filter as a simple binary classification task. And as a long-running query executes, we can dynamically find the thresholds to determine, using a smaller proxy model that is much cheaper than our larger LLM, when we can make a call to the cheaper model with high confidence. So we'll find these two thresholds, a lower bound and an upper bound. Anything below the lower bound, we can say with confidence, is a negative or false in the filter case. And above the high threshold filter, we can call that a confidently positive result. Values that appear in this uncertainty region, we will continue to push and cascade up to the larger model, which is a little bit more expensive, but this is going to improve the accuracy of the final result. We have a number of metrics here on a variety of open benchmark data sets demonstrating a pretty significant improvement in execution time with this cascade strategy, ranging from 20% to as much as 500% improvements with a small decrease in accuracy. Finally, I have another topic on query rewrites to optimize performance here. So in this case, we have another query using a join with an AI filter. We are looking for reviews that map to a specific product category. The naive implementation would do a cross-join. This would be very expensive. It would scale with the number of all candidate pairs. So we have reviews on the left, m of them, and we have n number of categories as candidate categories, let's say. In the most, naive implementation, you run both of them against all possible candidates, and this will scale with the cross product. If we can assert that, or identify in the query rather, that n is small, let's say it's less than 1,000, we will rewrite this query instead of as a join, but as a classification task, and handle the entire shot for the entire row. This movie was great. Instead of checking every possible candidate category, we will run them all in a single LLM call, significantly reduce cost. So this has some really nice results on both performance and the accuracy of the result. On a large number of benchmark data sets, you can see this roughly scales with the size of n. And some of these improvements go up to 70x on the speed side. But what's really nice is that for many of these classification tasks, the target outcome is mutually exclusive. And by giving the LLM context of all possible candidates, it actually does a much better job on the accuracy and F1 score as well. So for particular, the NASDAQ data set is matching a company, I think, article to a stock ticker. There's only one correct label. And by being able to view all of the possible outcomes and kind of sort or order or compare and contrast all of your candidates, we see an improvement from about 6% accuracy to nearly 80%, or sorry, an F1 score. So most of what I described today are these lower level primitives that are expressed as SQL queries. But this is really kind of a building block we think of in higher level agentic systems. So one of these new ones we have just shipped very recently is called Snowflake Intelligence. AISQL powers Snowflake Intelligence. So this is a chat-like interface where you can talk to your data and ask questions like, how are sales performing this quarter compared to the forecast? And yeah, as a result, Snowflake Intelligence will identify the table's relevance to this query, run the query until it finds a satisfactory result, and also display some results. And along with that, it will provide an explanation of all of the columns it identified. Cool, so thank you. That's everything I had for today. Again, most of this content came from this paper that is now available in archive. There's an accompanying blog post. Please check that out, called Optimizing Query Execution in Cortex AI SQL. And a huge thank you to Derek, who put together that demo earlier. Again, my name is Benjamin Hahn. I'll be around for the happy hour, so please feel free to reach out and chat. This is my email as well. Feel free to email me. Thanks.
Thank you, Benjamin. We have time for questions.
Hi, thank you very much. That was really interesting. If we look at the last slide where you were doing the general query to a result, we tried to do something similar to that and have worked with, at the end, where you went from a business like request and then to the AI, I assume some of the AI filters. Can you talk a little bit more about how you went from that natural language query into a SQL query of sorts, and then what types of queries get translated into, I guess, more traditional SQL or Snowflake SQL, and then into the AI filters or AI AG or AI summarize type statements?
Just to clarify, this is the slide you're referring to?
Yeah. And then the response and the graph and everything.
Yeah, I'll be frank, I'm not on this team, so I have less visibility in how this works. But the SQL becomes a tool that this agent has access to. I think one of the core building blocks of this system is we also have a layer called a semantic model, where you have a lot of, that's probably the root, you're nodding your head, that tends to be one of the cruxes of this type of problem, where you want lots of metadata for each table, you want to know your foreign keys and things like that. Yeah, that is a key component of that system.
Awesome, thanks.
I'll echo fantastic presentation. Is Snowflake Intelligence something that is considered as a potential white label solution, or is it mainly intended to be an internal to Snowflake tool for business analysts?
Internal in the sense that you are a customer on Snowflake and you do not intend to expose this to customers. It's like for your employees only,
Correct.
like documentation. That's a good question. Yeah, actually.
The answer is yes. Sorry, I'm also an AI/ML engineer at Snowflake, but more on the sales side. Snowflake Intelligence, you can white label it. You can put your own logo. You can customize the font and color scheme. And the goal is this is intended for business users as an application. But also there's the same REST API behind the scenes that you can also integrate into the front end of your choice.
I have a quick question. Have you also done any efficacy testing of natural language to SQL translation? Because a few months ago, Uber published a paper which is claiming like 80% of accuracy. How does it look like in your case?
I'm sorry, could you repeat the question after efficacy tests?
Yeah, from a natural language to SQL and then to the final result, what is an efficacy of these like translations? Because if you see the Uber paper they published and they said like 80% is the accuracy which they were able to achieve.
Yeah, I don't have the exact numbers on this. This is a slightly different product. As far as I know, the last I saw, our numbers on the text-to-SQL side outperformed the models we had available for evaluation, but I am more familiar with, let's go back to the product offerings. I think the comparison you're describing is within the Cortex Analyst product. I am more familiar with the AISQL side. The text-to-SQL side is kind of another product here. We are more of the building blocks of the functions that Cortex Analyst can start writing SQL to.